Hello, this is Aaron Zuckley. I'm here to present my final project for EEL6825 Pattern Recognition out of the University of Florida. Here's just a quick outline of the topics I'll be presenting in this PowerPoint, and then at the end of the video there'll be a short demonstration of my project. So, for what is optical character recognition? It's giving the ability for machines to read information from images, such as characters and in particular written information. It was originally developed for creating devices to read information to the blind, but other applications that have grown from this is helping robots to perceive their environment, such as being able to read street signs, displays, information on papers. It's also been used commercially for data entry. So if you've ever seen people with cell phones being able to take pictures of checks, this is one application for that, as well as scanning passports or getting mail addresses for the mailing system. Also vehicle plate recognition and document scanners. So just some related work on this topic. MNIST is a large data set of handwritten digits. You can see an example up here on the top right side. Another example is Google's Tesseract, which is an open source OCR. It's able to recognize over 100 different languages, characters, and it's also grown into the commercial sector with FineReader and OmniPage. The picture on the bottom right is an example of a combination of OpenCV and Tesseract being used to read license plates. So, kind of a project overview of what I accomplished for this project. It got broken down into 3 different stages. The first one being image processing, which performed the pre-processing for the neural network. It took in the images and basically sorted out the information that I wanted to feed in and taking out as much noise as possible. The second part was developing the data set for this project, so the pictures that would actually train the neural network. And then finally the neural network itself, the architecture, and how to categorize the information being sent in. So for the image processing side, OpenCV was used. It's a Python open source image library. And it was used, like I said, as pre-processing to remove as much noise as possible and really isolate the English characters that we're trying to identify. And for this project, we mostly considered something along the lines of like document scanning, where the images are mostly just text, maybe a little bit of noise, but not fully dynamic scenes, such as trying to read street signs or license plates. This is more mostly just the text, so mostly clean images. So kind of running through what the image processing side did as far as the individual functions. First, we converted from the color space into grayscale and black and white, just to remove noise and kind of clean up so that we have mostly just the text. Then a combination of morphology functions and finding contours were used. And morphology functions were basically used to accentuate the objects that we're trying to find. So the way this software works, first we're trying to identify the individual lines of text within the image, and then within each line of text, search for the individual characters to be found. The morphology helps to enlarge things and make it so that you see one total object for the objects that you're trying to find. And then finding contours is what's used to actually find those objects, and gives you like bounding boxes and things like that. Finally, scaling was used, so if the text wasn't the correct size, it would scale the image to 32 by 32 inverted grayscale. that would help for the neural network to have the correct size of data coming in. So for the training set development, a MATLAB code was created to generate these training data of 32 by 32 images. MATLAB has over 1,000 different available fonts. However, some of them were deemed incorrect for this application, being specifically made for either like Greek characters or really fancy calligraphy that don't really match other texts found for this project. So for this project, we are doing both uppercase and lowercase letters. So that gives us a total of 52 categories, leading to a total of 38,376 training images. And then, like I said, the format is 32 by 32 inverted grayscale. We just used the MATLAB text box function, so we create a text box in an image, put in whatever font we want at whatever size, and generate the text in an image form. For the training set, it was found that varying the location of the text, the font size, and things like that helped to get a higher percentage of accuracy on the system. And the reason for that is the data coming from the image processing isn't going to be perfectly centered. It's going to be close, but not perfect. So by making sure that the average is centered, but there's variations in the training data, helps to account for differences between the two and increases the percentage of accuracy for the system. So for the neural network, two Python libraries were primarily used: Keras, which is the high-level neural network API, and Theano, which is an efficient multidimensional array operation library, which basically handled the background tasks for Keras. The input, like I said, is 1024 for the 32 by 32 pixel images. And we had two hidden layers, 512 nodes each, at a dropout rate of 20% to help with overfitting. And finally, your 52 categories using softmax, so whichever category had the highest number at the end of the neural network won. For training, we used 20 epochs and 128 different batch sizes. So what that means is, of the 38,000 training data, it was grouped into 128 training set groups. So you'd have 128 pictures in a batch, and those would then get trained, and then you'd move on to the next batch. Once you went through all the data, that would be one epoch. And going through all the epochs finally gave you the full training of the system. So for the results of how the system performed, we were able to achieve an accuracy between 86 and 92% over 5 images and 500 letters. Best results really happened when we had clean characters, as far as characters that weren't touching, and characters that were very distinct. So you start running into issues with very similar letters, such as O, capital O and lowercase o, or lowercase l and uppercase I. They're just very similar and hard to distinguish between the two. As well, minor tuning had to happen on the image processing side, just because you have contrast differences, and that's going to lead to a little bit more or less noise depending on what the image is. So in conclusion, we were able to achieve an accuracy above 85% with moderately clean images. Just some of the lessons kind of learned. Pre-processing was really important to the accuracy of the system. If you have a lot of noise or poorly centered data and things like that, it's not going to perform well. As well, the training data, as much as you can accurately represent what you're going to be trying to find, the better the system's going to be. So things like misalignment, so if the average center of the characters is not centered or not where you're expecting actual information to be, you're going to be hurting your performance as well if you start getting weird shapes and scales that you're not going to be looking for. That starts to hurt the performance. And then for the neural network, in general, it works well, as you can see, with 85% for this topic. However, with some of those characters, this system alone will probably never get close to 100% just because of those similar letters. If you have like I said, in lowercase l and uppercase I, even humans can't distinguish between the two with just that character. So having an extra system such as word recognition, where now you're looking at groups of characters and how that fits a given set of words, that can really help to find those errors and correct the errors that are occurring. So some of the improvements that can be done: dynamic thresholding or convolutional neural nets to be used for the image processing and pre-processing side, just to be a little bit more dynamic and better at feature extraction. Also for the database side, just representing more information, and also doing almost like a feedback system where the correctly labeled letter images taken from images themselves, feeding those into the training data would also improve the percentages. For more on the functionality side, being able to identify spaces, so starting to look at the word grouping or separating by line, just cleans up the output a lot better and opens up the doors for more like word recognition and other systems after this one to be implemented. And like I said, word recognition systems would also be a good application to add on to the system to find those errors and really give you a clean output. So here's just some of my references if you want to look at what I've used for this project. So now I'm going to switch over to the actual demo and we can see how the system performs. So first I'm going to show you just what the sorry for that. So this is going to show you what the training data looks like. So this is what the training data looks like. It's just a random sample of some of the characters, and you can look at the fonts and how some of the text is moved around and things like that. And you can see, so like some of the extreme cases, the I there or the M, just show what's some of the differences in the training data. And then for the actual system itself, so here's kind of the 4 images. The original image is right here, so you can just see, here's the text. This is the thresholded image that shows any noise or things like that. And then up here you have the bounding boxes for each row. And then finally the bounding boxes for each character, just showing that each character was found. So then looking at the neural network side, this just shows some of the inputs and sizes and stuff of what was found. And you can see the accuracy here. So achieving a 92% accuracy on this data set. And for the output, just to show you what it looks like, this is the output that was generated. So you can see the 2 rows are both on one line. You can see an error here, so this should be an I instead of an L, or here's an E instead of a C. but in general it's pretty close. So I hope you liked my project, and thanks for watching.